Merge Sort Algorithm Overview, article, by AI Matrix. Because we're using divide and conquer to sort, we need to decide what our subproblems are going to look like. Divide by finding the number q of the position midway between p and r. Do this step the same way we found the midpoint in binary search. Add p and r, divide by 2, and round down. Conquer by recursively sorting the subarrays in each of the two subproblems created by the divide step. That is, recursively sort the subarray array, p, q, and recursively sort the subarray array, q plus 1, r. Combine by merging the two sorted subarrays. Back into the single sorted subarray. Array, p, r. With p equals 0 and r equals 1, compute q equals 0, recursively sort array, 0.0, 14, and array, 1.1, 7, resulting in array, 0.1, still containing 14, 7, and merge the first half with the second half, producing 7, 14. Finding the midpoint, q in the divide step, is also really easy. In the next challenge, you'll focus on implementing the overall merge sort algorithm to make sure you understand how to divide and conquer recursively. Want to join the conversation? Button navigates to sign up page. Button navigates to sign up page. Based on pseudocode. Merge sort, array A, int p, int r. If p less than r, we have at least two items. Q equals p plus r, 2. Merge sort, A, p, q, sort A, p, q. Merge sort, A, q plus 1, r, sort A, q plus 1, r. Merge, A, p, q, r. Merge everything together. For merge sort on arrays with less than 2 elements, the function is do nothing. The second copy of the function will return and vanish. Button navigates to sign up page. Comment on Ravi Sankaran's post. Hi, my program runs fin. P is the index of the first element of the subarray. Comment on Cameron's post. The merge step takes 2. The example given shows subarrays of array 0.0 and array 1.1 as the base case. If you like this hard work, like and share to this video, and hit the subscribe button for more video like this. Thank you.